The next topic of discussion is Weibull distribution and uniform distribution. So we will be moving ahead with the types of continuous random variable and types of distribution for the continuous random variable. Initially, we have covered with the binomial distribution, Poisson distribution, which were for the discrete random variable. For continuous random variable, the most important one was normal, which is through the normal curve, standard normal curve. The next distribution, very easy to understand and very rarely used actually, the Weibull distribution. So a continuous random variable x is said to be Weibull distributed with parameters alpha and beta which are greater than 0. Now in this particular distribution, there are two different parameters used. One of the parameter is alpha, other parameter is beta, both are greater than 0. The density function is given by f of x is equal to alpha into beta x to the power beta minus 1 e to the power minus alpha into x to the power beta for all x greater than 0, strictly greater than 0. For x less than or equal to 0, the value of this probability function is 0, or in the case of a continuous random variable, we call it as a density function. So हर जगह हमेशा for any kind of distribution we calculate the probability function or the density function depending on the nature of the random variable which is given. So in this case also, the density function is given by f of x is equal to alpha into beta x to the power beta minus 1 into e to the power minus alpha into x to the power beta for x greater than 0, where alpha is greater than 0 and beta is greater than 0. For beta is equal to 1, Weibull distribution reduces with the parameter alpha. The mean of Weibull distribution mu is alpha to the power minus 1 by beta gamma of, this is a notation used for gamma function, gamma of 1 plus 1 upon beta. So mean mu for the Weibull distribution is this. Variance of Weibull distribution is given by sigma square, which is alpha to the power minus 2 by beta gamma of 2 by beta plus 1 minus gamma of 1 by beta plus 1 whole square. Expectation of x square minus expectation of x whole square. That is what the logic is behind calculation of the sigma square. So Weibull distribution has applications in reliability theory. It is assumed as the distribution of length of life, that is the time to failure of a component in a system. Shelf life या length of life जो बोलते हैं, that is to be calculated with the help of this distribution, and therefore it is having applications in reliability theory. Other distribution describing the failure law are exponential and normal distribution. This distribution provides close approximations to the distribution of the lifetime of a component. The failure rate is not a constant but is proportional to the rate of change of a time exponent, and that is what is the major application or the broad area related to the Weibull distribution. So kindly remember the formula for the Weibull distribution, the density function which is given by, and the example related to the Weibull distribution. Suppose that the lifetime of a certain kind of battery in hours is a random variable having Weibull distribution with alpha as 0.1 and beta as 0.5. In the question itself, they have mentioned that how the random variable is distributed, which is Weibull distributed. Also, it is connected with the lifetime of a certain battery calculated in hours, that is in proportional to the time component, and accordingly we go ahead with the density function for the Weibull distribution. Find the mean lifetime of these batteries, that is mu. The probability that such a battery will last more than 300 hours, probability that a battery will not last 100 hours. See, calculation of these big large quantities is not possible with the help of discrete random variable by doing the calculation distinctively. It has to be a particular range. Whenever it is a range, we try to find out the answer with the help of integration. And continuous random variable is responsible when you do the actual integration. So as per the requirement, the very first quantity what I have to calculate is mean lifetime of the batteries. What is the formula for the mean? Mean mu is alpha to the power minus 1 by beta gamma of 1 plus 1 upon beta. So mean mu is alpha to the power minus 1 by beta gamma of 1 by beta plus 1. In the problem itself, they have given you value of alpha as 0.1, value of beta as 0.5. So mu is equal to 0.1 raised to power minus 1 upon 0.5 multiplied by gamma of 1 upon 0.5 plus 1. Use the property gamma n plus 1 is n gamma n, else convert it into the whole number. 1 upon 0.5 यानी क्या होता है, डेसिमल हटाने के लिए मल्टीप्लाई बाय 10, ठीक है, 10 upon 5, राइट, 10 upon 5 is 2, 2 plus 1 is 3, तो gamma 3 is 2 factorial, पता है ना, gamma n is n minus 1 factorial, so gamma n means gamma 3 is 2.1 factorial, 2 factorial, 3 minus 1 factorial, 2 factorial is 2, 0.1 ka whole square, and accordingly we can simplify and get the answer. So that is how what I am getting it as 2 upon 0.01, which is 200 hours. So what is the mean for the given random variable? Mean mu is 200 hours. Now, second is the probability that such a battery will last more than 300 hours. So let X denote the lifetime of the battery. More than 300 hours means still infinity, indefinite period, indefinite hours. So random variable X is between 300 to infinity. So integration of f of x between 300 to infinity of f of x dx. This is how the formula is. So integration of f of x between 300 to infinity dx. So that is how the formula is. Now what is the formula for the Weibull distribution? Alpha into beta into x to the power beta minus 1 for x greater than 0, e to the power minus alpha into x to the power beta. This is what the simplification is. So I am using the formula alpha into beta into x to the power beta minus 1, e to the power minus alpha into x to the power beta dx. Put the value of alpha, put the value of beta, simplify it, integrate it, you will get the answer. That integration comes out to be 0.177. Probability है, hours में calculation की जरूरत नहीं है, so you keep the answer at it. Secondly, it will not last 100 hours. Means मैक्सिमम इसका लिमिट कितना है, 100 है, 100 के ऊपर नहीं जाएगा. बट कहां से? फ्रॉम द लेफ्ट हैंड साइड. फ्रॉम द लेफ्ट हैंड साइड मींस इट स्टार्ट्स फ्रॉम माइनस इंफिनिटी, बट आवर फंक्शन is defined only for greater than 0. X is strictly greater than 0. So मेरा लिमिट कहां से चालू होगा? 0 से 100 तक चालू होगा. So accordingly you integrate this appropriate terms between 0 to 100. That answer will be giving you this. Simplify it, you get the answer, and the answer is 1 minus 0.36788. I think this is e to the power minus 1. E to the power minus 1 means 1 upon e. 1 upon e plus 1. Simplify it in the calculator. Apply the rule of integration. Get the answer, and that will give you the simplification as this. So accordingly, we try to simplify and get the answer. The answer is 0.63212. So this is how the probability is calculated where it will not last more than 100 hours. So not more than 100 hours means upper limit, upper bound is 100, lower limit is minus infinity. But वो भी कहां से होगा, जीरो से होगा, क्योंकि ये जो फंक्शन है ये किसके लिए डिफाइंड है, जीरो ऑनवर्ड, x ग्रेटर देन जीरो, उसके लिए we will be integrating it between 0 to 100. So this was one of the standard example related to the Weibull distribution. Another example is the lifetime of a component measured in hours is Weibull distributed with parameters alpha is equal to 0.2 and beta is equal to 0.5. Find the mean lifetime of the component which is mu, जिसको expectation भी बोलते हैं, probability that component will be more than 200 hours. More than 200 hours यानी क्या, 200 to infinity, कहां तक जाएगा पता नहीं. So do that particular integration, you will be getting down the answer as 0.059. That is your answer for the required probabilities, where the random variable is Weibull distributed and we are actually interested in calculating the lifetime of the component. The parameters alpha and beta are mentioned. This again gives you the hint that the distribution to be used is the Weibull distribution. Next is, each of the 6 tubes of a radio set has life in years, which is a random variable that follows a distribution with parameters, Weibull distribution with parameters alpha is equal to 25 and beta is equal to 2. If these tubes function independently of one another, what is the probability that no tube will have to be replaced during first 2 months of the सर्विस? ये जो कैलकुलेशन है ये ईयर्स में दिया है आपको, फर्स्ट 2 मंथ्स. सो ईयर में हाउ मेनी मंथ्स आर देयर, 12. सो 2 मंथ्स के लिए रेशियो आपका लेंगे अकॉर्डिंगली डिपेंडिंग ऑन द 2/12. 2/12 will be the point over there. Take the fraction and integrate it appropriately. Your answer should be obtained as 0.0155. So these are the examples related to the Weibull distribution, which is one of the distribution applicable for the continuous random variable, usually measuring the lifetime of the component in the various time intervals or the